7-2 on the quiz. We're not ready for it. I wanted to be able to give you some time to ask questions and if we need to review more. 7-2A is more important than 7-2B. 7-2B is just some information I kind of wanted you to see, but we'll need to continue with the 7-2A stuff as we go. So the quiz looks very much like you see here, a similar order, similar stuff. There are some things you're just going to have memorized, and then some things you have to use. The first thing you have to have memorized is your SOHCAHTOA stuff. I will have a triangle to the side. Please label based upon my theta, where is the opposite, where is the adjacent, and where is the hypotenuse. Once you've labeled that, these will be blank. I will have them in the same exact order as you see here because that's the order I want you to memorize them anyway. Remember, because of SOHCAHTOA, sine is opposite over hypotenuse. Adjacent is, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I would write those three down first. So those are your original SOHCAHTOA. Again, they will be in that order. After you have done those three in this order, these are our reciprocals. Our reciprocals are as follows. The reciprocal of the sine is the cosecant. It is going to be right next to it. So just take your opposite over hypotenuse and write hypotenuse over opposite. The reciprocal of our cosine is the secant. It will be right next to it. So take your adjacent over hypotenuse. It becomes hypotenuse over adjacent. And then our tangent, opposite over adjacent, the cotangent is the reciprocal, so it becomes adjacent over opposite. So that first section will be just like that. Those six things, write those down for me. You could if you, but no, we're not going to. If you want to remember it like that, you can. So just remember, you're going to have to fill those in for me. That's the first piece that you have to have memorized. The next piece is the law of sines. So you're going to just have to fill that in. There's not going to be anything there. It's just going to be a blank spot for you to write that the sine of angle A over little a is the sine of angle B over little b, which is the sine of angle C over little c. You will have to use that formula later on some of the problems, but it just says law of sines next to it like this. And then you're going to fill that in, okay? Now, there is a little triangle here just to help you remember, but for both of these, you would use a non-right triangle. The law of cosines, you have to have memorized that one. It very much follows your Pythagorean theorem that c squared is a squared plus b squared minus 2ab cosine of c. But if you memorize the two versions that you see there, you will get yourself some bonus points. They're all derivatives of the same thing because we don't have one locked in as our hypotenuse. Just remember that the angle matches whatever you started with. That's a good way to go. Your angle matches whatever it started with. And then these are the other two sides, a squared plus b squared, and those same sides sit right here. So watch all of them. Match, other two sides. Match, other two sides. So you have to have that memorized. We will use it for one of the problems. If you don't take the time to memorize it, you're going to be in a world of hurt when we get to the problems that use it. I will give you Heron's formula. You will not need to have that memorized. You will just need to know how to use it, okay? So the top of the quiz will have these three items that you have to have memorized. SOHCAHTOA, law of sines, law of cosines. Again, Heron's formula will already be in that spot waiting for you. I don't need you to memorize that. Okay, now that we've gone through the things that you have to have memorized, the next problems are using those things, okay? It is going to be in a similar order that you see here. The first two sets are going to be for right triangles. Then we'll do some problems with non-right triangles. Do we have any questions about the things you have to have memorized? Okay, now that we know what you have to have memorized, so please study that. Let's take a look at our examples. The first example and the second example, those two problems on the test are about right triangles. The first thing you have to do is find the exact values of the 6 trig functions for theta. So there's going to be a right triangle shown. And when you look at that right triangle, the first thing you want to kind of look at is, do I know all 3 sides? And you might notice right off the bat that we are missing our hypotenuse. So let's call that C. So we know that a squared plus b squared equals c squared. And then if we call a 5 and b 10, it doesn't matter which, because those are the legs of a right triangle. 5 squared is 25, 10 squared is 100, that's 125. And see right here where it says exact values. If you give me the decimal equivalent of that, it's 11 point something, I'm going to say, nope, that's not the exact value, because you're going to have to round it. I want the square root for this in simplified form. So C is the square root of 125. And remember, to simplify a square root, you need to find, are there any perfect squares that are divisible into that? Well, 125 is 5 times 25. And so that would be 5, because the square root of 25 is 5. That would pop in the front and leave a normal 5 behind. Okay, so I want exact values in simplified form. Let me say that again, exact values in simplified form. That's how you are correct. Okay, I will take not a lot off if you give me an unsimplified form, but I will take something off. Okay, so once you have the sides, do not proceed with your problem until you have labeled said sides. Okay, even on the top, I expect you to label the SOHCAHTOA portion of that triangle. Okay, so go here, find where your theta is. I suggest finding the one across from it first. That is our opposite. The longest side across from your 90 is your hypotenuse. And the one attached to it, the leg attached to it, is your adjacent. Now you're ready to go. Okay. Now that we're ready to go, let's fill in. I would go sine, cosine, tangent in order of the way you wrote them up at the top. Please do that for me. I think I might even put a little spot for you to put them. The sine is opposite over hypotenuse. That is the exact answer. It isn't in the correct form. I want it in correct form. Let's get it in correct form. Now, to simplify a fraction with a radical, I want the radical only in the top, and I want it reduced. So there's a few different ways to go about this. 5 does go into 10 2 times. So you could write it as 2 over radical 5. And then we have to rationalize it. How do you rationalize? Just multiply the same radical on top and bottom. What happens is it pops that to the top and leaves a normal 5 behind. So it pops the radical to the top and leaves a normal 5 behind. So rationalize your final answer, reduce your final answer. Now let's move on to the cosine. The reason we label our triangle is because then we can easily pull out what we need. Cosine is adjacent over hypotenuse. So that would be 5 over radical 5. No, 5 over 5 radical 5. Sorry about that. 5 over 5 radical 5. Adjacent over hypotenuse. 5 goes into 5 one time. So that's 1 over radical 5. We got to rationalize. Multiply by radical 5 on top and bottom. We get radical 5 over 5 is our simplified answer for that one. Everybody good with sine and cosine so far? Okay, next, tangent. Go back to your triangle. Tangent is opposite over adjacent. Opposite over adjacent is 10 over 5, which reduces down to 2 over 1 or 2. So again, I want the 6 trig functions in fractional form, exact values, no decimals, reduce as much as possible. Now, once you have found those, we know that the cosecant, the secant, and the cotangent are their reciprocals. So flip over whatever version floats your boat. Just make sure your final answer is rationalized and simplified. I like this version for this one because it'll instantly do those things for me because I've already reduced it. It'll put the radical in the top. So that would put radical 5 in the top and 2 in the bottom. If you flip over any version and simplify, you will always get radical 5 over 2. So if you did this version or this version, you will still get that answer. It just will take you a little longer, okay? So flip over the one that makes it as simplified and beautiful as you can, okay? I would flip over this one, which is radical 5 over 1 or radical 5. I would probably flip over this one, which is 1 over 2. Okay, so flip over the one that you've already done the work. Find the one that's nicest to flip over. All of them will reduce down to the same version. So if you pick something different, it's okay. You still will get what you should get, okay? Do we have any questions about the first type of actual math you're going to do? So it's a right triangle. You're going to list those 6 trig functions, be done with it, reduce it, stop. No calculator. Well, you can use a calculator if you need to do some pieces, but I need exact values, okay? Now, see how number 2 says to round. So that's a really good indication that number 2 is a calculator problem. You're going to need a calculator, okay? Also, you should notice that there is a corner right triangle. Since there is a corner that's 90 degrees, I know I can use any of my Pythagorean or SOHCAHTOA stuff to answer the question. Now, I'm going to show you the way that occurs to me. There's lots of ways because you might use a tangent and I might use a sine, we might use different things. That's okay. Okay, so let's look at number 2. If they say to me to solve the triangle, let's look at what we need to know for this particular one. I don't know side C, I don't know angle A, and I don't know angle B. So there will be 3 things, and I even put a little thing on the side to guide you. There's 3 things we got to find in this particular problem. If I know 2 sides of a right triangle, I can use a trig function, but the most effective way is to actually go about and just do Pythagorean theorem. So let's go ahead and do Pythagorean theorem. I know this is little a, this is little b. I know that a squared plus b squared has to equal c squared, and you get 4 plus 49, which is 53. And so c is the square root of 53. Now, in this particular one, the square root doesn't reduce down further. It's a prime number. You can't break down 53 any further in a square root. There's no square root divisible into 53. So that is what it is. Let's put it on there. And let's put it over here. Okay. So now we need to find some angles. The only time you need to look for angles, or the only time we hit second on our calculator is if we need to look for angles. So it doesn't matter which we start with. Let's start with A. We'll just go alphabetically. Okay. So I know that based upon what I was given, and if I look for A in particular, that this is the opposite and this is the adjacent. Now you could have used the hypotenuse we found, but I like to use what was on the paper in case I messed that square root of 53 up. Then that's going to mess up my angle value. So I use what's there. That's a tangent. So I know that the tangent of angle A is opposite over adjacent. Now, if you use a sine or cosine, it would have to be a proper fraction. Tangent doesn't have to be. If it is a proper fraction, like 2 over 7, that just means that A is less than 90. Or it's a small angle. Okay, so we're going to hit in our calculator. You have to hit the second button. then the tangent, okay? That little -1 notation should only appear on the calculator when you are looking for an angle measure. And make sure your angle, it's in that degree mode. You should see a little DEG on the corner of your screen or it's going to mess you up, okay? So if we do the inverse tangent, so second tangent, the little -1 appears again. You would put in the 2/7. If it's a nice fraction like that, you can put the ABC button, 2/7, or you can just always do 2 divided by 7. Okay. And then when rounded to the nearest degree, like they told me to, that is 16 degrees. So let's put that here. And then let's put that over here. Now it's a right triangle. So we had to have a 90-degree angle to begin with. And we just found that it's 16 for A. So angle B is 180 minus off 90, which is always 90. And so minus off 16 from that. And we get 74, I believe. Okay. So now we have all missing sides and all missing angles. Let's do a little quick check that we talked about before. The smallest side is across from the smallest angle, check. Our medium side is B. It's across from 74, our medium angle. Yes, check. And our largest side is across from the largest angle. Yes, check. So that's just a really good way to kind of check my work. Did I do that right? Okay. Everybody okay with solving a right triangle? Okay. So that is solving a right triangle. So you can use Pythagorean, SOHCAHTOA, and the 180 rule for right triangles. Now that moves us to question number 3, which is a non-right triangle. Okay, so let's take a look now at question number 3. Question number 3 says to solve the triangle, it's not a right triangle, so how do you proceed? Well, the first thing you check for is, do we have any opposite side pairs? So we are missing D, so no, that's not a full pair. We're missing angle E, no. We're missing angle F, no. So we don't have a full pair. So the one on the test will be where you have to use the law of cosines as your first step. So since we only know angle D, we must start with side D, okay? So I'm going to write down the law of cosines that starts with D. So D squared is E squared plus F squared minus 2EF cosine of D. Now let me remind you why it's like that so that you don't freak out. This is just the Pythagorean theorem. And you just add this extra junk. Now, what is it, the extra junk, and what is the, okay. These two should appear by the 2. So EF, 2EF. These should be across from each other, D and D. That's how way you can tell it's right. So these two are across from each other. These two should always be the other stuff, the other sides, okay? It's always like that. It doesn't matter what the letters, you can call them, M, J, Q. It doesn't matter. As long as these two are across from each other and these two are the other junk. That's how the law of cosines work. Okay, so let's fill in the values. So I know D squared is 49 squared plus 40 squared minus 2 times 49 times 40 times the cosine of 53 degrees. Okay, so let me talk you through it one more time. These two are the other sides, E and F. E and F appears by the 2 here back on the back. This should always be the angle across from the whatever side you start with. Okay. The reason it actually is the Pythagorean theorem in general, the cosine of 90 degrees is always 0, so it makes it work even for a right triangle. Anyway, you got to throw that into a calculator. Remember, I told you this is a calculator one. So if you throw all that junk into a calculator, make sure you're in degree mode again. And we get, not that, let me do it one more time, 49 squared plus 40 squared minus 2 times 49 times 40 times the cosine of 53. Oh, there we go. Okay. We get 1,641.8851. Now, I just kind of wrote it out because I need something on the paper to show you. But if I was doing it on my calculator, I would just leave that value in my calculator, and then I would take the square root of that. And the square root of that, because it's a side, we're going to follow the instructions and round to the nearest tenth. So I know that D is 40.5. Now, let's look at our triangle for just a moment. This is 40.5. D is 40.5 as side length. F is 40 as a side length. See how close those are? I expect angle F is super close to 53. It's got to be a little bit less, maybe 52, maybe 51. But it's a good indication that these two angles are super close to one another. Yes. So you might, if someone asked about how do you leave that number in your calculator, on my red ones in the back, or if you look up on this poster here, see the little ANS, the answer? It's above the minus key at the bottom. If you hit second and then answer, it'll populate the last answer that was in your calculator. So it just pulls that last answer out of the calculator. That's how I did it. I had that answer in my calculator, that 1,641 answer. I hit second, no, I hit square root. Then I hit second, the answer button, and it populated it from the last time. And then I didn't even have to retype it. So that answer button will always pull out the last number that you put into a calculator. Okay, so now we have side D. We still need to find angle E and angle F. Now, since we have a sense that angle F should be close to 53, probably a little bit smaller, 52, 51, let's go with angle F next. Once you use the law of cosines, you never have to use it again. We can go to the law of sines. So I know that sine of D over little d is my finished pair. So now I can use the law of sines. And I said I want to find F because F is probably something close to what I know. So let's do the sine of F over little f. So once you use the law of cosines, you never have to do it again. We now can focus on the law of sines. So if we put into our calculator the sine of 53 times 40 divided by 40.5, just cross multiply, we get that the sine of f is 0.788775. Now again, that's an answer that's populated into my calculator. So this is a great time to use that answer thing. But remember, you're going to have to do the inverse sine of that answer. And that is going to be what f is. So the inverse sine is you have to hit second sine of that decimal 0.788 answer. And we get, oh, guess what? My conclusion is correct. It's 52 degrees. So that's great. We now are only missing angle F. Well, angle F, we know, would be 180. Take off the 53 and take off the 52. So 180 minus 53 minus 52 is 75 degrees. Oh, angle E. Thank you. I'm sorry. Yes, I sure did. That is 75 degrees. Now, once we have all the pieces and parts, just do a quick little check. Did I make a mistake? Okay. So angle E is 75, angle F was 52. Okay. So if we put that into our actual triangle, the smallest angle is across from the smallest side, medium, medium, largest with the largest. Hey, I probably did it right. You know that it'll rear its head if it was wrong, because it just will go, hey, something's weird. So it's a great way to just check your work. So look how fast it took me to check my work. Do we have any questions about solving a non-right triangle? Yes. Yeah. Uh-huh. I am not going to be super picky about the rounding, because if you round a little sooner than me, so as long as you're close, I'm going to give it to you, okay? Okay, the last thing on the quiz tomorrow is the Heron's formula. So let's talk about Heron's formula. I have given it to you at the top of the page, and that will be true on the quiz tomorrow. You don't need to have it memorized. We just need to know how to use it. The first step on Heron's formula is to find the half perimeter, which they've labeled S. Now, remember, side D was 40.5, side E was 49, side F was 40. So those are the A, B, and C, the sides we're going to use. And if you even want to call those, if you want to call that A, B, and C, it does not matter what you call the sides of your triangle. You can substitute A, B, C for D, E, F, or any letters that you want. So if you like calling it A, B, C, so it fits the formula profile a little nicer, we're going to make A 40.5, B is 49, and C is the 40. Just go alphabetical. That's what I usually do. Okay. So the half perimeter, we're going to take half of 40.5 plus 49 plus 40. Just how do you find the perimeter of a triangle? Add them up, divide by 2. That's your half perimeter. So 40.5 plus 49 plus 40. And it's more accurate if you keep any decimal places. So the answer is 64.75. That's your half perimeter. Okay? Okay. Now that we've done the half perimeter, next we can actually jump into the area formula, which is the square root of that number we just found, times that number from each side individually. Okay, so 64.75, our half perimeter, minus our first side, 24.25. Our half perimeter, 64.75, minus our next side, 49. That's 15.75. Our half perimeter minus our last side of 40 is 24.75. Okay, so let me remind you what just happened again. It is going to be the square root of our half perimeter minus our side A, or our first side, half perimeter minus our next side, half perimeter minus our last side. So you just get those numbers in a calculator, throw it down, you got it. Okay, so now we're going to square root that. So the square root of 64.75 times 24.25 times 15.75 times 24.75. And then you can end your parenthesis, which means all that stuff is in your square root. And our area is 782 point, let's go to the nearest tenth, 4 square units. Now, I did not give you units on the test, so it's just square units of some sort, who knows? And that would be the area of the triangle in number 3, okay? So on the test tomorrow, on the quiz tomorrow, there are the memorization portion. You will have to know your SOHCAHTOA, law of sines, law of cosines. I'll give you the half, or the area formula. Then there'll be a find the 6 trig functions exactly, reduced square roots as much as possible, solve a triangle that's a right triangle, you'll use a calculator. Solve a triangle that's a non-right triangle, law of cosines, law of sines, Heron's formula, that's your quiz, okay? So, do we have any questions about what you're going to see on the quiz tomorrow? So, your job for the rest of the period is, have you finished up all of 7-2? Turn that in. All of the stuff that's on the quiz, 7-1, 10-1, 10-2, did you do that? So use the rest of the time in class to make sure you're caught up. Study for the quiz. Quiz is tomorrow on paper. It looks like this. There you go.